Every atom is trying to disappear. Inside it, everything is pulling inward with enormous force. By all ordinary logic, atoms should collapse, crush themselves, and vanish in an instant. But they don't. They stay open, stable, quietly existing for billions of years. That means something very strange is stopping them. Not a wall, not a glue, not a simple force. Something deeper, something almost unsettling. Once you see what really keeps atoms alive, you'll never look at matter or yourself the same way again. Outline 1. Why atoms don't collapse inward. Imagine you shrink yourself down until the entire world is made of atoms. Not pictures of atoms, real ones, tiny nuclei with electrons around them. Now here's a strange question that sounds almost silly, but is actually very deep. Why don't atoms collapse? Think about it. An atom has a heavy, positively charged nucleus in the center. Around it are tiny, negatively charged electrons. Opposites attract strongly. If you learn just a little electricity, you would expect the electrons to rush straight into the nucleus and stick there forever. But they don't. Every atom you have ever touched has been quietly refusing to collapse for billions of years. Tables, air, your body, stars, all of them depend on this one simple fact. Atoms stay open. They don't fall in years. So why? Let's start with the most tempting wrong idea. You might imagine electrons as little planets going around the nucleus, like the Earth goes around the sun. Planets don't fall into the sun because they're moving sideways fast enough. So maybe electrons survive because they're orbiting, spinning around, always missing the center.
That picture is helpful at first, but it's not true.
If electrons were really tiny charged balls orbiting like planets, they would lose energy, charged objects that accelerate, give off radiation. That means they would spiral inward, lose energy, and crash into the nucleus in a tiny fraction of a second. Atoms would be dead almost instantly. But atoms exist, so something else must be going on. Here's the key shift in thinking. Electrons are not little balls moving on neat paths. They are quantum objects, and quantum objects do not behave like things in everyday life. An electron is better thought of as a fuzzy spread out presence, not here or there, but kind of everywhere around the nucleus at once, more like a standing wave than a particle you can point at. And this fuzziness is not optional. It's built into nature. There is a rule in quantum physics that says you cannot know both the position and the motion of a particle exactly at the same time. The more tightly you try to squeeze an electron into one place, the more violently its motion becomes uncertain. This rule is not about bad measurements. It's about how the universe works. Now let's use that idea. Suppose the electron tried to collapse inward, right into the nucleus. That would mean it's squeezed into a very tiny space, extremely tiny. The nucleus is incredibly small, but squeezing the electron like that has a price. When you confine a quantum object to a small region, its kinetic energy goes up a lot. It's like forcing a wave into a very short length. The wave has to wiggle faster and faster. So as the electron moves closer to the nucleus, two things are happening at the same time. Electric attraction is pulling it inward. Quantum motion is pushing back, not by force in the usual sense, but by energy. The electron's motion becomes more energetic the more you try to confine it. At some point there is a balance, not a peaceful balance, but a restless one. The electron finds a state where going closer would require too much kinetic energy, and going farther would increase electric potential energy. That state is the lowest energy arrangement the system can have, and that's what we call an atom. The atom exists because collapsing further would actually cost energy, not save it. This is very different from everyday intuition. In daily life, falling inward usually lowers energy. A rock falls down, a ball rolls downhill. But in the quantum world, squeezing something too tightly makes it energetic and unstable. So the electron doesn't crash. It spreads out. This spreading is not because it wants to. It's because nature doesn't allow it to be perfectly localized without paying a huge energy price. Now here's something even more interesting. The electron is not sitting still in this balance. It's not frozen. It's constantly fluctuating. Its position is uncertain. Its momentum is uncertain. The atom is alive with motion even at absolute zero temperature. This restless motion is sometimes called zero-point motion. Even when everything is as cold as possible, electrons are still moving in a quantum way. So atoms don't collapse because they are never truly at rest. Matter exists because of motion. If electrons could stop completely, atoms would shrink dramatically. Chemistry would change. Life would be impossible. Now let's zoom out a little. The same idea explains why matter takes up space, why you can't push your hand through a table, why solids feel solid. When you try to squeeze atoms together, you are not just fighting electric forces, you are fighting quantum motion. The electrons resist being confined into smaller regions. This resistance shows up as pressure, quantum pressure. It's not pressure from heat, it's pressure from the fact that electrons cannot all sit quietly in the same small space with low energy. So, the simple question, why don't atoms collapse inward, turns into a deep answer. Atoms exist because nature refuses to allow perfect stillness and perfect localization at the same time. Attraction alone would destroy atoms. Motion alone would let them fly apart. Reality exists in the tension between the two. And here's a beautiful twist. This balance is not designed. It's not planned. It's not trying to make atoms. It's simply what happens when electric forces and quantum rules coexist. The universe didn't need to know about chemistry or life. It only needed these basic principles. Everything else follows. Now think about this next time you look at something ordinary. A glass of water, the wall, your own hand. All of it exists because electrons are not allowed to sit still and fall inward. Matter is stable not because it's rigid, but because it's restless. And that's one of the quiet miracles hiding inside every atom. Outline 2. Balance between attraction and motion. Let's start with something that feels obvious. So obvious that we rarely question it. Things stay the way they are. A table stays a table. Air stays spread out. You stay solid instead of collapsing into a tiny dot. But once you zoom down to the level of atoms, that obvious fact becomes strange. Because inside every atom, there is a powerful attraction trying to pull everything together. Positive and negative charges attract. They don't gently attract, they pull hard. The nucleus of an atom is positively charged, and electrons are negatively charged. So from a simple point of view, everything should rush inward, fast. End of story. But that's not what happens. Atoms exist, and they exist in a very specific size. Not too big, not too small. Always the same scale. That already tells us something important. There must be a balance, not a static balance, like two equal forces pushing against each other, something more subtle. A balance between attraction and motion. To see why motion matters, imagine a world without it. Suppose electrons were allowed to sit perfectly still. No fuzziness, no uncertainty, just tiny particles sitting calmly in place. In that world, attraction would win completely. The electrons would fall straight into the nucleus and stay there. Atoms would be microscopic points with no size. Chemistry would vanish. Matter, as we know it, would not exist. So the fact that atoms have size already tells us motion is essential. But this motion is not like planets orbiting stars. That picture is useful for beginners, but it hides the real mystery. Electrons are not little balls going around in circles. They don't have precise paths. Their motion is quantum motion. An electron behaves more like a vibrating cloud than a flying dot. It spreads out. It explores space. And the more space it has, the calmer its motion becomes. Here's the key idea. Motion costs energy, but confinement also costs energy. If you force an electron into a small region, you increase its kinetic energy. It has to wiggle faster. Its wave gets shorter. Its motion becomes more intense. If you let the electron spread out, its motion calms down. But now electric attraction pulls it inward more strongly. So the atom becomes a kind of negotiation. On one side, electric attraction says, come closer, lower your potential energy. On the other side, quantum motion says, if I do that, like kinetic energy explodes. The electron finds a compromise, not because it's thinking, but because the lowest energy state of the system sits exactly at that compromise. That state is what we call a stable atom. This is not a fragile balance. It's surprisingly robust. Disturb the atom a little, and it settles back. Push it too hard, and it changes state, or breaks apart in predictable ways. But the basic balance remains. Attraction alone would destroy structure. Motion alone would dissolve it. Together they create form. Now let's slow down and really feel this idea. Imagine holding a spring. If you compress it, energy goes up. If you stretch it, energy also goes up. Somewhere in between is a natural resting length. Atoms are like that. But the spring is made of quantum rules and electric forces. The electron does not sit at a single distance from the nucleus. It occupies a region, a probability cloud, and that cloud has a size determined by the balance we're talking about. Shrink the cloud. Motion energy rises. Expand the cloud. Attraction energy rises. Minimum total energy sits in between. That's why atoms have a size. And here's something beautiful. That size is not arbitrary. It comes directly from fundamental constants. The charge of the electron, the mass of the electron, Planck's constant. Change any of those and atoms would be very different. So the shape of matter is written into the rules of the universe. Now let's connect this to everyday experience. Why does a solid resist compression? Why does pushing on a wall feel hard? Because when you push atoms closer together, you disturb this balance. You try to force electrons into smaller regions. Quantum motion pushes back, not as a conscious resistance, but as rising energy. That energy shows up as force. What you feel as solidity is actually the universe saying, this balance doesn't want to change. Even empty space is not truly empty. Inside atoms, there is motion everywhere. Electrons moving in allowed quantum states. Always active, always restless. This is why matter does not collapse inward under its own electric attraction. But there's another layer to this story. Electrons are not allowed to all sit in the same state. This rule, called the Pauli exclusion principle, adds another kind of motion pressure. It forces electrons to occupy different quantum states, spreading them out even more. This makes atoms bigger and more complex. It gives rise to shells. It creates chemistry. So balance is not just between attraction and motion of one electron, but among many electrons all obeying quantum rules that prevent crowding. The more electrons you add, the more structure appears. And still, collapse never happens. Instead, you get order. Now think about stars. In stars, gravity tries to collapse matter inward, but motion and quantum pressure push back. When gravity finally overwhelms those pressures, stars change form. White dwarfs, neutron stars, black holes. Even on cosmic scales, existence depends on balance between attraction and motion. Atoms are the smallest stage where this drama plays out. And here's the quiet lesson hiding inside all this. Stability does not mean stillness. Stability comes from movement that cannot stop. Matter exists because it is never completely at rest. If electrons could stop moving, atoms would shrink. If attraction disappeared, atoms would fly apart. Reality sits between those extremes. So the next time you think of atoms as tiny solid things, replace that image with something more alive. A dance, a constant negotiation, forces pulling inward, motion pushing outward, energy flowing but never settling. That balance is not a detail. It is the reason anything exists at all. And that's why atoms don't collapse inward. Not because attraction is weak, but because motion is unavoidable. The universe refuses to choose one over the other. And in that refusal, matter is born. Outline. 3. Quantum pressure holding matter apart. Let's begin with a strange idea that sounds almost wrong the first time you hear it. Empty space can push, not because there is air in it, not because something is hiding there, but because of the rules of quantum physics. This quiet pushing is called quantum pressure, and without it, matter would collapse into nothing. Everything solid, depends on this invisible resistance. To understand it, forget atoms for a moment and think about crowds. Imagine a small room filled with people. If you keep pushing more people into the room, it becomes harder and harder to squeeze them in. Not because the people are made of iron, but because they need space to move. They need freedom. They can't all stand in the same place doing nothing. Electrons are like that, except far stranger. Electrons are not tiny balls sitting quietly. They are quantum objects, described by waves. And quantum waves have a rule. They hate being confined. When you try to squeeze a quantum wave into a smaller region, its energy goes up. The wave has to wiggle faster. Shorter wavelength means higher kinetic energy. That rising energy shows up as pressure. Not air pressure, not thermal pressure, quantum pressure. Now place this idea inside an atom. At the center is a tiny heavy nucleus. Around it are electrons, attracted inward by electric force. That attraction is strong. If nothing opposed it, electrons would fall straight in. But something does oppose it. As electrons move closer to the nucleus, they are forced into a smaller region of space. Their wave functions become more confined. Their motion becomes more energetic. That energy increase is not optional. It is enforced by nature. So as attraction pulls inward, quantum pressure pushes outward. Not as a force with a direction, but as an energy cost that grows rapidly when you try to compress the system. At some point, the energy cost of squeezing the electrons further becomes greater than the energy gained by attraction. That point is where the atom settles. This is why atoms have size. This is why electrons do not sit on the nucleus. This is why matter does not collapse. Now let's make this idea more concrete. Imagine trying to trap a wave in a tiny box. The smaller the box, the faster the wave must oscillate to fit inside. Faster oscillation means more energy. If the box becomes extremely small, the energy becomes enormous. Electrons inside atoms are trapped in a kind of natural box created by electric attraction. The nucleus pulls them inward, but quantum rules say you can't shrink the box without paying a huge energy price. That price is quantum pressure. This pressure is always there, even at absolute zero temperature. Even when there is no heat at all, electrons still resist confinement. So this pressure is not about temperature. It is about existence. Now let's zoom out from one electron to many. In real matter, electrons don't live alone. They share space with other electrons. And here another quantum rule enters. Two electrons cannot occupy the same quantum state. This rule forces electrons to spread out. If you try to pack them into the same region with the same motion, quantum mechanics refuses. So as you add more electrons, they must occupy higher energy states. States with more motion, more pressure. This creates an even stronger resistance to compression. This is why atoms with many electrons are larger. This is why chemical structure exists. This is why the periodic table has shape. Quantum pressure builds structure. Now think about solids. When you press your hand against a wall, you feel resistance. That resistance is not because atoms are hard little rocks. It is because electrons in your hand and electrons in the wall are being forced into smaller regions of space. Quantum pressure rises sharply. You are not touching the wall in the everyday sense. Your electrons are pushing against the wall's electrons through electric forces, and both sides resist being confined. What you feel as solidity is quantum pressure pushing back. Now let's take this idea to an extreme. In stars, gravity tries to crush matter inward. At first, thermal pressure from heat pushes back. But when the star cools, another pressure takes over, electron degeneracy pressure. This is quantum pressure on a massive scale. Even when electrons are cold, they cannot all collapse into the same low energy state. Quantum rules prevent it. Their motion creates pressure that can hold up an entire star against gravity. White dwarf stars exist because of quantum pressure. If gravity grows stronger, even electrons cannot resist forever. Then neutron pressure takes over, and beyond that even quantum pressure fails, and black holes form. So this tiny idea inside atoms scales all the way up to cosmic objects. But let's come back to everyday matter. Why does a table have a fixed shape? Why doesn't it slowly shrink over time? Because the electrons inside the atoms are already as confined as they can be without increasing the total energy. Any further squeezing would raise quantum pressure, and nature avoids that. The table is stable not because it is static, but because it sits at a minimum of energy shaped by quantum pressure. This is the key insight. Matter exists not because forces cancel, but because energy finds a minimum. Attraction pulls inward. Quantum pressure pushes outward. The balance point is where energy is lowest, and that balance is incredibly precise. Change the electron's mass slightly, and atoms would be different sizes. Change Planck's constant, and chemistry would be unrecognizable. So the everyday world is tuned by quantum pressure. Now here's the part that feels almost philosophical. Quantum pressure comes from uncertainty, from the impossibility of knowing position and motion exactly at the same time. In other words, matter exists because certainty is forbidden. If the universe allowed perfect knowledge and perfect stillness, everything would collapse. Instead, uncertainty keeps space open. Restlessness creates stability. So when you hold an object, you are holding organized uncertainty. You are touching motion that cannot stop. And this is why atoms don't collapse inward. Not because there is a solid core holding them apart, but because the rules of quantum physics create a pressure that refuses to let matter shrink beyond a certain point. It's a quiet pressure, invisible, but it holds up the world. And once you see it, you realize that solidity is not about stiffness. It's about motion, trapped, confined, and endlessly pushing back. That is quantum pressure. And without it, there would be no atoms, no chemistry, no you. Outline 4. Stability from restless atomic movement. Let me tell you something that sounds backwards at first. Things are stable because they never stop moving. Iraq looks calm. The table looks still. Your body feels solid and quiet. But deep inside, at the level of atoms, nothing is calm. Nothing is still. Everything is moving all the time. And that motion is exactly why things stay the way they are. If atoms ever became perfectly still, matter would collapse. Structure would disappear. Stability would be lost. So the secret of stability is restlessness. Let's slowly unpack that. Inside every atom, there is a nucleus and electrons. The nucleus is heavy and positively charged. The electrons are light and negatively charged. They attract each other strongly. That attraction is always there, pulling inward. Now ask a dangerous question. What would happen if the electrons stopped moving, not slowed down, not cooled, stopped? If that were possible, the electrons would fall straight into the nucleus. Nothing would prevent it. The atom would shrink dramatically. Chemistry would vanish. Matter would become something unrecognizable. So the fact that atoms exist already tells us electrons never stop moving. But this motion is not like bouncing balls. It's not random chaos. It's quantum motion. The electrons don't travel on clean paths. They spread out. They behave like waves trapped around the nucleus. And these waves cannot sit still. Even at absolute zero temperature, electrons still have motion. This is not heat. This is zero-point motion. It comes from the rules of quantum physics, not from energy added from outside. Nature does not allow a particle to have both exact position and zero motion. The closer you try to pin it down, the more motion it must have. So, inside an atom, electrons are constantly in motion, not because they're excited, but because stillness is forbidden. Now here's the surprising part. That constant motion is what keeps the atom stable. As electrons move, they resist being confined too tightly. If you try to squeeze them closer to the nucleus, their motion becomes more energetic. That energy increase pushes back against further squeezing. So attraction pulls inward. Motion pushes outward. Not as two forces fighting, but as a balance of energies. The atom settles into a state where motion and attraction are perfectly matched. Any change in either direction would raise the total energy. That is stability. Not frozen equilibrium, but dynamic balance. Think of it like riding a bicycle. You don't stay upright by being still. You stay upright by moving. Stop moving, and you fall. Atoms are the same way. Their stability comes from movement that never stops. Now let's zoom out a little. This restless motion does not belong to just one electron. All electrons in matter obey similar rules. And they also obey another powerful rule. No two electrons can occupy the same quantum state. This means electrons must spread out. They must occupy different patterns of motion, different energy levels, different spatial regions. As more electrons are added, motion increases. Structure becomes more complex. Atoms develop shells. Chemistry appears. All of this comes from motion refusing to settle. Now consider a solid object. Why does it keep its shape? Why doesn't it slowly shrink over time? Because the electrons inside the atoms are already in their lowest allowed motion states. If you try to compress the object, you force electrons into smaller regions. Their motion energy rises. They push back. What feels like rigidity is really resistance to disturbed motion. What feels like solidity is organized restlessness. Now think about temperature. When you heat something, you add extra motion. Atoms vibrate more. Bonds stretch. Eventually the structure breaks. The solid melts. Then it becomes a gas. So too much motion destroys stability. Too little motion would also destroy stability. Existence lives in between. Atoms survive because they have exactly the kind of motion that keeps them from collapsing, but not so much that they fly apart. Now here's a subtle but important idea. This motion is not happening in time, the way we usually imagine motion. It's not like watching a particle trace a path. It's more like a standing wave, constantly present. The electron's motion is built into its state of being. So when we say electrons are restless, we don't mean they are bouncing around randomly. We mean their very existence includes motion. Being is moving, and this has a profound consequence. It means stability is not about locking things in place. It's about allowing the right kind of motion. This is why atoms can survive disturbances, shine light on them, and they jump to new motion states. Remove the energy and they return to their original patterns. They are flexible because they are not rigid. Now let's push this idea further. The same principle applies on larger scales. In stars, gravity pulls matter inward. Motion and pressure push outward. When that balance is lost, stars change form. In planets, gravity pulls inward. Motion of atoms and internal pressure hold shape. In your body, molecules constantly vibrate, react, and rearrange. Yet your form persists. Stability everywhere comes from controlled motion. Absolute stillness would be death for structure. So when you look at the world and see things standing still, remember this. What you are really seeing is motion so well balanced that nothing changes. Atoms are like dancers frozen in a pose that only exists because they keep moving. And here's the quiet wonder in all this. The universe did not need to design stability. It did not need to plan atoms. It only needed rules that forbid perfect stillness. From that refusal, matter emerges. From that restlessness, structure is born. So atoms don't collapse inward because they are never allowed to stop moving. Their stability is not the absence of motion. It is motion itself, trapped in a beautiful balance. And that is one of the deepest lessons hiding inside ordinary matter. Outline 5. Existence born from competing tendencies. Let's begin with a simple thought that sounds almost philosophical, but turns out to be very physical. Nothing in nature gets everything it wants. Everywhere you look, there are competing tendencies. One thing pulls one way, another pushes back, and reality forms in the middle. Atoms are a perfect example of this. Inside every atom, there is a powerful desire to collapse. Positive and negative charges attract. They want to come together. From a simple point of view, that attraction should win. Everything should fall inward and stay there. But something else is happening at the same time. Electrons are quantum objects. They are not allowed to sit quietly in one place. They spread out. They move. They resist being confined. So right away, we see two tendencies. Attraction wants to shrink the atom. Quantum motion wants to spread it out. Neither can win completely. And from that conflict, atoms are born. This is the key idea. Existence is not built from peace. It is built from tension. If attraction were a little stronger and motion a little weaker, atoms would collapse. If motion were a little stronger and attraction weaker, atoms would not hold together. Matter would dissolve. But the universe sits right in between. Now let's slow down and really feel this balance. Think of attraction first. The nucleus of an atom is positively charged. Electrons are negatively charged. The electric force between them is strong and long range. It never turns off. It always pulls inward. Left alone, attraction wants simplicity. Everything in one place. Lowest potential energy. End of structure. Now think of the opposite tendency. Quantum mechanics forbids perfect localization. The more tightly you try to trap an electron, the more energy its motion must have. This is not a choice, it's a rule. So motion wants space. It wants freedom. It wants to spread the electron out. These two tendencies do not compromise politely. They fight through energy. As the electron moves inward, attraction energy decreases, but motion energy increases. As it moves outward, motion energy decreases, but attraction energy increases. There is a point where the total energy is as low as it can be. That point is the atom. The atom is not a thing added to the universe. It is the natural result of competing tendencies finding a minimum. This is why atoms have a size. This is why that size is stable. This is why matter has structure. Now notice something important. Neither tendency disappears at the balance point. Attraction is still pulling inward. Motion is still pushing outward. The atom exists because both are active all the time. Stability is not the absence of conflict. It is conflict held in balance. This idea shows up everywhere in physics. In a stretched spring, force pulls back while motion carries it forward. In an orbit, gravity pulls inward while motion carries the object sideways. In a star, gravity crushes while pressure resists. Atoms are the smallest stage where this drama plays out. Now let's add another layer. Electrons are not alone. In real atoms, many electrons share space. And here, another tendency enters. Electrons are not allowed to be identical in every way. They must occupy different quantum states. This rule forces them to spread out even more. So now we have attraction pulling everything together, motion pushing outward, and exclusion preventing crowding. From this three-way tension comes complexity. Shells form, chemistry emerges, bonds appear, molecules assemble. None of this was planned. It is simply what happens when competing rules operate together. Now let's connect this to the world you experience. Why does matter feel solid? Because when you try to push atoms together, you disturb the balance. You increase confinement. Motion energy rises sharply. The system resists. That resistance is not a wall. It is the universe refusing to move away from its energy minimum. Why do objects keep their shape? Because any change would require upsetting the balance of tendencies that created that shape in the first place. Why does chemistry work? Because atoms can share electrons in ways that create new balances of attraction and motion. Molecules are just new compromises. Now here is the deep lesson. Existence is not built from a single principle. It takes at least two opposing ideas to create structure. One tendency alone gives monotony. Two tendencies together give form. If the universe only had attraction, everything would collapse. If it only had motion, nothing would hold together. Reality exists because neither is allowed to dominate completely. This is not just true for atoms. It's true for all stable systems. Life exists because reactions pull molecules together, while energy flows keep them from freezing into crystal perfection. Planets exist because gravity pulls inward while motion carries them sideways. Even thoughts exist because stability and change coexist. Atoms teach us this lesson quietly. They show us that existence is not about winning. It's about balance. And this balance is not static. Atoms are alive with motion. Electrons fluctuate. Fields vibrate. Energy shifts constantly. Yet the overall form remains. This is dynamic stability. Now imagine a universe without this competition. Imagine a universe where everything settled into a final motionless state. Nothing would happen. No structure, no time, no complexity. Instead, we live in a universe that never quite settles. There is always tension, always movement, always competing tendencies. And from that, everything emerges. So when you hold an object, you are holding a frozen argument between attraction and motion. When you breathe air, you are inhaling atoms that exist because no rule was allowed to dominate. When you look at yourself, you're seeing the result of countless balances stacked on top of each other. Atoms don't collapse inward. because the universe refuses to make things simple. It insists on conflict, and from that conflict, matter is born. That is one of the deepest truths hiding inside the smallest things. Existence is not a single story. It is the space where stories collide and refuse to cancel each other out. And in that space, everything we know comes into being.